most important question. Prove that, please write down, prove that the set S is equals to hmm, hmm, hmm. Hmm, 1 0 1 0 1 1 1 1 0 is a basis of R cube. Okay, now listen carefully, very interesting point. And sorry, and find dimension. Now let's careful. So from here it is from the, suppose you have this question. So this type of question you can see in your question paper. So now we want to prove that this set of vector is a basis of R cube. Okay. Now if we can prove it, that this set of vector is a basis of R cube. Now anyone can tell me what will be the dimension of it? Dimension of R cube?
3.
3, sir.
Absolutely.
Yes, sir, 3.
Yes, you are correct. Now we are going to prove it. Now, if we can write, for example, now listen carefully. So this total is a R cube, okay, and one portion is a S. Now, if we can prove that this S, this set of vector S is linearly independent, and if we can prove number 2, it is a spanning set. If it is possible to prove that this set of vector S is linearly independent as well as spanning set, then we can say this set S is a basis of R cube. Is it clear or not?
Sir, please repeat once.
Please repeat.
So if we can prove that this set of vector S is linearly independent as well as a spanning set, if we can prove it, then we can say this S is a basis of R cube.
Yes, sir.
Yes, sir.
Sir, R cube is the total.
Total, big part, that is JISU, our university.
Yes, sir. Okay.
Part is your department.
Yes, sir. CSI department.
Correct. Clear?
Yes, sir.
Now.
Yes, sir.
Okay. Now, so from here it is clear that we have two parts. One is linearly independent, another is spanning part. Okay. Now, solution. So please write down here S is equals to 1 0 1 0 1 1 1 1 0. Okay. So now we are going to test for linearly independent part. Exam time, no need to write, but this is the first time I'm explaining, that's why I'm writing. Independent part. Okay. Now let us consider the relation. So can you recall how to check linearly independent? So already you know that. How to check linearly independent part? Anyone?
So C1 alpha 1 plus C2 alpha 2 plus C3 alpha 3 equal to theta.
Yes, very good. C1 alpha 1 plus C2 alpha 2 plus C3 alpha 3 is equals to theta. Very good. Now we can write down where What is alpha 1? Alpha 1 is equals to 1, 0, 1. What is alpha 2? 0,
1 1 0.
1,
Sorry, 0 1.
okay. What is alpha 3 is equals to 1, 1,
110.
okay. And what is theta? Theta is a null vector. Okay, now you substitute everything over here. So from here you can write C1 1 0 1 plus C2 0 1 1 plus C3 1 1 0 is equals to 0 0 0. Is it clear? Is it clear?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Now please check, can you write like this? If I can write component wise addition, that is C1 plus 0 C2 plus C3 comma 0 C1 plus C2 plus C3 comma C1 plus C2 plus 0 C3 is equals to 0 0 0. Can you write this?
Yes, sir.
Yes, sir. Yes, sir.
First component C1 into 1 plus C1 C2 into this and C3 into this, first component wise. Okay, now shall I move to the next slide?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Now from here you can write, that is C1 plus 0 C2 plus C3 equal to 0. 0 C1 plus C2 plus C3 equal to 0. C1 plus C2 plus 0 C3 is equals to 0. Now we want to check, we want to find the value of C1, C2, C3 by using Kamasu. Now you write down what is your del. That is 1 0 1 0 1 1 1 1 0. Now if I can simplify the determinant calculation part, so we may write 0 minus 1 minus 0 0 minus 1 plus 1 0 minus 1. Can I write?
Yes, sir.
So
Yes,
minus 1, our value is coming minus 2, not equal to 0, correct?
Yes, sir.
Yes, sir.
Everyone please check. So if it is not equal to 0, now anyone can tell me what should be the del 1, del C1, because del C1 means this first column replaced by this 0 0 0, isn't it, by Kama's rule?
Yes, sir.
Yes, sir.
Yes, sir.
So if already you know from the determinant concept that if any one or any column of a determinant becomes 0, the corresponding determinant value will be 0, correct?
Yes, sir.
Yes, sir. Yes.
Where you can write del C1 equal to 0, del C2 equal to 0, del C3 equal to 0. Am I correct?
Yes, sir.
Because
Yes, sir.
for C1 you should replace the first from del first column by 0 0 0, and for del C2 the second column should be replaced from del 0 0. Apart from this, all are remain same. For del C case, that is this 0 0 0 should be replaced by 1 0 1 1 0. So ultimately you can see in del C1 or del C2 or del C3, everywhere you can see one column becomes 0. It means the corresponding determinant value will be 0. So that's why I have mentioned here. So here you can write C1 is equals to del C1 by del. It means 0 by minus 2 is equals to 0. C2 is equals to del C2 by del is equals to 0 by minus 2 equal to 0. And C3 is equals to del C3 by del is equals to 0 by minus 2 is equals to 0. So therefore you can write C1 is equals to C2 is equals to C3 is equals to 0. So that means all constant are 0. Now, if you already know, if your constant becomes 0, then what will be the conclusion?
Linearly independent.
Yes. So please write down
Sir, can you please show the previous slide?
this one.
Previous one. Yes, sir.
Okay. It is okay.
Yes, sir.
Yes,
So
sir.
now you can see C1, C2, C3 becomes 0. So now you can write down. Therefore, the set you have 1, 0, 1, 0, 1, 1 and 1, 1, 0 is linearly. Is it clear? Anyone, any doubt about the calculation? Linearly independent part?
No, sir.
No, sir.
No, sir.
No,
No,
sir.
sir.
Okay. Now we are going to discuss about the second part. Second part means spanning part.
হ্যাঁ আগে ফ্যাক্টটা দেখাবেন
Just a minute. This one.
ইয়েস স্যার ওকে স্যার থ্যাংক ইউ
Okay. Now listen carefully. Spanning set means what? You have to identify the representative. You have to identify the representative. Okay. So that means by which you can explain or you can represent everything about that. Okay. Now we are going to test the set
Sir.
of vector. This set of vector is a spanning set, yes or no? Yes, please. Anyone? Any other question?
স্যার ওই লাস্ট স্লাইডটা একটু দেখাবেন
This one.
ইয়েস স্যার ওকে ওকে ওকে
Okay. Now try to understand. Let beta belongs to R cube. Beta belongs to R cube. Be any or you can write, if you can write in as easiest way, suppose beta is equals to you can say ABC, A B, or you can write suppose A1 B1 C. Oh, we can use same C1. If you can write okay, beta 1 beta 2 beta 3, it will better. I think I think you should consider a little bit different form for you better understand. Okay, I can consider A B C belongs to R cube. Now listen carefully. I am considering a beta vector from R cube. What is the component ABC? You don't know the actual value. You don't know actual value. Now we want to check, can I represent this beta with the help of the given set of vector? Now we want to test it. If possible, beta is equals to A1 alpha 1 A2 alpha 2 plus A3 alpha 3. Listen carefully. So that means we want to check, can I represent this beta new vector with the help of this alpha 1, alpha 2, alpha 3? Correct. So already you know what is your alpha 1, alpha 2, alpha 3. That means here we can write what is beta? Beta is equals to ABC. What
Sir,
is
A1, A2, A3 are the components.
A1, A2, A3 are constant.
Okay, sir, like C1, C2, C3.
Yes, like C1, C2, C3.
Okay, sir.
Now, what is your alpha 1? Anyone? What is your alpha 1?
101.
1, 0, 1. Already you know that. A2. What is alpha 2?
011.
0, 1, 1. Okay. What is your alpha 3?
Sir, 110, sir.
1, 1, 0. I think it is clear because it is a given information. It is a
Yes,
given
sir.
information. Correct. So already you know that. Now let's see, is it possible to express this ABC with the help of these three vector? How we can prove it? If we can identify some value of A1, A2, A3, if we can, if we're in this position to find some valid value of A1, A2, A3, then only you can say that this new vector can be expressed with the help of these three vector. Are you getting my point?
Sir, please repeat, sir, Atlanta.
Basically, what you are writing here in this line, you have mentioned a linear combination of these three vector with ABC. If we can identify the some valid value of A1, A2, A3, then we can say that this vector can be represented with the help of these three vector. Okay, again, if you have a doubt, then I can give you some numerical example. Now let's see. If you have a doubt, now come to the next slide. Now try to understand. Suppose the standard basis is basically you have 1, 0, 1, 0, 1, 0 and 0, 0, 1. So this is a standard basis. Now we can try to understand 2, 3, 1. We can write 1, 0, 0. Listen carefully. 0, 1, 0 plus 0, 0, 1. Now if you can write 2 here and 3 here and 1 here, if you add all together, you will get that one. Are you getting my point?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, similarly, another example, suppose we want to take minus 2, 3 minus 1. Same process, 1, 0, 0 plus 0, 1, 0 plus 0, 0, 1. Anyone can tell me what will be the value?
Minus
Minus
2, 3, minus 1.
Minus 2.
Yes, minus 2, 3 and minus 1.
Minus 1.
Is it clear?
Yes, sir.
So from here it is clear.
Yes, sir.
Whatever the vector you can want, with the help of these three vector, you can express. So that's why this set of vector is a standard basis. So our main part to identify the value. Can you find the finite value? Real finite value? Yes or no? If it is possible to find out, then you can say this vector can be expressed with the help of these three vector. Are you getting my point?
Yes, sir.
Yes, sir.
So
Yes, sir.
Yes, sir.
in your problem, the set of vector is different. The set of vector is different. Now we are going to test it. Is it possible to express all vector with the help of these three vector? We are going to test it. Correct or wrong?
Yes, sir.
Correct.
Okay, now. So now if we can write, that is A, B, C Is it possible to write? Already you know that A1 plus 0 A2 plus A3 0 A1 plus A2 plus A3 A1 plus A2 plus 0 A3, like previous calculation. Can I write this?
Yes, sir.
Yes, sir.
So now here we can write A1 plus 0 A2 A3 is equals to A 0 A1 plus A2 plus A3 is equals to B A1 plus A2 plus 0 A3 is equals to C. Can I write this?
Yes, sir.
Okay.
Yes, sir.
Now our objective to find the value of A1, A2, A3, isn't it? If we can find some unique value, then only you can say that this arbitrary vector ABC can be represented with the help of these three vector. Correct?
Yes, sir.
Yes, sir.
Can you repeat?
Yes. Which part should I repeat?
Sir, this last line, sir, representation.
So from this to this is, I think it is clear, from this to this line.
Yes, sir. Yes, sir.
Now we are going to check. This is a set of system of linear equation where
Yes, sir.
A1, A2, A3 are unknown. A1, A3, A1, A2, A3 are unknown. You want to find the value.
Yes, sir.
Find the value. Okay. So by Kama's rule, we can check.
Yes, sir.
Basically, what you have, this is a non-homogeneous system of three equation in A1, A2, A3. Why it is called non-homogeneous? I think you have a question in your mind. Non-homogeneous means if on the right side part, if all are zero, then it is called homogeneous equation. If any one is non-zero, then it is called non-homogeneous system of equation. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Homogeneous, what is
Yes, sir.
non-homogeneous? On the right side part, that is green colored zone, if all are zero, then it is called homogeneous equation. Then as a total is called homogeneous equation. Okay. And if you can see at least one on the right side part, if non-zero, then you can say the set of linear equation is non-homogeneous. Okay.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So already you know the determinant part. What is del? That is, you have 1 0 1 1 0 1. Second portion is 0 1 1 0 1 1. Then is 1 0 1 1 1 0. Then you write down 1 1 0. The same determinant you have. If you simplify, please check. It should be 1 into 0 minus 1 minus 0 into 0 minus 1 plus 1 into 0 minus 1 is equals to minus 2, not equal to 0. Correct? So from
Sir,
here,
अगर
Yes,
से-
sir.
Okay, sir. Okay, sir.
okay, so from here, what you have, this is a set of system of linear equation where A1, A2, A3 are unknown. A1, A2, A3 are unknown. Then you write down 1 1 0 1 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 Okay, so determinant become non-zero means what? By Camus rule, there exist unique value of A1, A2, A3. Is it clear or not? So already you know, if your determinant becomes non-zero, it means what? There exists unique solution.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so your unique value of A1, A2, A3 depends on your A, B, C, correct? Because when you
Yes, sir.
place the right hand side part on the determinant part, so your result become in terms of A, B. So here you can say that what is ABC? What is ABC? Basically, what is beta? Basically, beta. What is beta? It's an arbitrary vector. Correct. It's an arbitrary vector.
Yes, sir.
From here it is clear that therefore beta is equals to ABC can be expressed as a linear combination of the set of vectors one zero one 0 1 1 1 1 0. So therefore 1 0 1. So this arbitrary vector, so you can write 1 0 1 0 1 1 1 1 0 is a spanning set of RQ. So number one, your set of vector is linearly independent. Number two, your set of vector is a spanning set of RQ. So you can write therefore 1 0 1 0 1 1 and 1 1 0 is a basis of RQ. Okay, and also you can write the dimension. Oh, already you so that means it is proof. It is a proof.
Yes, sir.
So you can
Yes, sir.
proof part is over. Okay, so next is dimension. Just need to write down the dimension of RQ is 3. Why it is 3? Anyone can tell me why it is 3?
Sir,
Sir,
there
because
are
the set of
three sets.
vectors are three vectors.
Yes, you can write because n of s. What is s? This set of vector, that means this is your s,
Yes, sir.
isn't it? Okay,
Yes, sir.
n of s is equals to 3.